This is an introductory lesson to scientific notation for Math 8. What is scientific notation? Scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. Scientists often work with very large or small numbers. Using zeros to keep track of place values can be tedious with numbers like the following two. Scientific notation uses exponents to make it easier to work with such numbers that are really big or really small. This is scientific notation form. C, which is the coefficient, is a number greater than or equal to 1, but less than 10. This is always multiplied by a power of 10, which is raised to an exponent that must be an integer. This exponent does not tell you the number of zeros in your result. It tells you the number of places the decimal point has been moved. If the decimal place is moved to the left, the exponent is positive. Therefore, very large numbers require positive powers of 10. If the decimal place is moved to the right, the exponent is negative. Therefore, very small numbers require negative powers of 10. Which numbers are in scientific notation? Teacher, please pause the video to allow students to have time to work before answers are shown. The following numbers in red are not written in scientific notation. Please take a few seconds and discuss each example and why it is not written in scientific notation with your partner. Be sure to pay attention to the base, coefficient, and exponent. Why use scientific notation? You are less likely to make mistakes reading or writing very big and very small numbers if you use scientific notation. It also makes it much easier to tell at a glance which numbers are bigger or smaller without counting long strings of zeros. If we start with this number and want to convert it to scientific notation, remember the goal of scientific notation is to have a coefficient that is greater than 1 but less than 10. To do this, we will move the decimal point to now have the coefficient of 7. We move this decimal point 4 places to the right. How many decimal places we moved it, in this case 4, will tell us what our exponent will be. And since we moved it to the right, this tells us that our exponent will be negative. So now our coefficient is 7 with the decimal point and then 4, and this is multiplied by a base of 10. Remember, in scientific notation, the base is always 10, and this will be raised to the negative 4th power. Since we moved it to the right by 4, it's negative, and since we moved it 4, that's where the 4 comes from. We start with the number 6,700 and want to convert it to scientific notation. Remember, all whole numbers have a decimal point and a 0 after them. The goal of scientific notation is to have a coefficient that is greater than 1 but less than 10. So we will move this decimal point to the left 3 times to have the coefficient of 6. We move this decimal point 3 places, so our exponent is going to be 3, and since we moved it to the left 3 places, this will be a positive exponent. So now we have the number 6.7, and it's going to be multiplied by 10. Remember, your base is always 10, and it's going to be to a positive exponent of 3. Many people use scientific notation in real life, such as chemists, astronomers, engineers, and architects. Please write the following in scientific notation. Teacher, please pause the video to allow students to work before the answers are shown on the following screen. Now let's take what you have learned and work backwards. Convert the following from scientific notation form to decimal form. Please pause the video as you are working. Answers will be shown on the next screen. Please read and complete the following word problem. Pause the video as you are working. next class, we'll be learning how to add and subtract with numbers written in scientific notation.